Okay. In general, I've got my length ratio. And to do the area of the face, this is length ratio squared. Perfect. To do the whole surface area, length ratio, good, squared, it's the same. And then to do the volume, cubed. Yep. Don't forget, guys, this is a really good kind of cheat for you. If you forget that your ratio of your area is just your ratio of your sides squared, then just remember your units. And you're like, oh yeah, I just cube my side ratio to get that. Okay, let's take a look at example 1. Okay, so in this one, ratio of the radii is 5 to 7. Is the radii length, area, or volume? Length, you got it. Ratio of the volume. Okay, you guys do that. Find the ratio of the volume. You can look at your notes. Yeah. It's a radius. Yeah. Do you know it? So, Angel, did you get our volume ratio? (125 over 343). Is that what everybody else got? Give me a thumbs up if that's what you got. Oh, you guys are so good. Awesome. Oh, yeah, sure. Yeah. All I had to do, thanks for stopping me. All I had to do is cube both sides. I could do that one of two ways. In my calculator, I just enter 5 times 5 times 5, and that gives me 125, which is this right there. Or, also in my calculator, I say 5, caret what? 3. 5 caret 3. And that'll also give me 125. I do the same thing with 7. Thanks for keeping me honest, Michael. It's going too fast. Surface areas is a little bit trickier. What am I dealing with? Surface area. Okay. So area ratio 49 over 100. How did I get that? This right there. What is the ratio of the volume? Guys, can I go directly from area ratio to volume ratio? What do I have to find first? Say it. Yeah, the similarity ratio, or also known as the length ratio. So, how do I find just the length ratio? I gotta take one step back. How do I do that? I square root it. Square root it. Yeah. So I'm square root both of these. Let's square 49. 7. Square 1? 10. So the ratio is 7 over 10. I'm just going to call it LR 7 over 10. So to find the volume ratio, what do I do to the length ratio? Cube it. And then I find volume ratio. It is here. I'll put it up here. Three over 1,000. Okay. Examples 3. The city of Bridgeton had plans to make a small wading pool in the shape of a rectangular prism. They have decided to make a larger lap pool. Alright. So with this one, why don't you guys try it yourself? Draw it. My hint is they don't tell you how large that small wading pool is. So make one of the sides of the small wading pool 1. Oops. Wading pool. Try that. It may not be obvious to you right now as to how to do it, but go ahead and write that stuff down, play around with it, draw out those two shapes, and after that, just play around with it, can't figure it out, it's fine. As do we do, you have to use carefully. So did anybody figure out how the volume of the lap pool will compare to the volume of the wading pool? Even? No, not 3 times. Anybody want to give a guess? Yeah, Dominic? 1,000 times. Very good. So, how'd you get that? So you're saying you cubed 10? Good. So, if you have, let's put it over here. Here's my little pool. Boom, 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 boom. Boom, 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 boom. And this side is 1. And here's my big pool. And this side is 10. Right? Well, what's the ratio of lengths? 1 to 10. How did I get that? Because they've decided to make a larger pool with dimensions 10 times the dimensions of the wading pool. That means your length is going to be 10 times your length. So 10 times 1 is 10, of course. And whatever it would be, this will be 10 times what the smaller one is. So basically you just know that your length ratio is 1 to 10. Once you know that your length ratio is 1 to 10, you can say that your volume ratio is whatever that is cubed. Well, 1 cubed, it's easy. 1. 10 cubed, 1,000. So that means the small one is going to have a volume of 1, and the large one will have a volume of 1,000. Okay. Let's look at this one. Mine are cool and green. Yours, sadly, not. Now this talks about how to figure stuff out when the change is not proportional. Guys, we talked about the small pool going to the large pool in every dimension. We're going to change the length by 10. We're going to change the width by 10. We're going to change the height by 10. But in this one, we only change one thing. Let's call this the length. The old length is 1. The new length is 3. But old width is 1, the new width is 1. Old height is 1, the new height is 1. So, how do you think that's going to affect the volume if only one side is multiplied by 3? Say it again? Say it again? Well, it'll just be this, right? It'll just be this shape. So it's definitely not the shape of the old one. But what about the volume? Well, let's see. Volume of the old is 1 times 1 times 1, length times width times height. What's the volume of the new? 3 times 1 times 1. 3. So if you only multiply one side, your volume is 3 times as much. Let's look at the next one. Length is still 1, 1, 1. But in this one, the length is 3. And the width is still 1. But now the height is 2. So that's right. So if I multiplied one side by 3 and the other by 2, then my volume on the new is going to be 6 times the old. So basically, guys, to find the find the change in volume of something that's not proportionally changing all at the same time? Just multiply what you multiply each side by to get that volume. In this one, it's 3. The length is 4. And then the height is 2. And this is just 1, 1, 1. Old is 1. And Sergio, what is the new one? 24. That's it. Okay. Example number 4. A rectangular prism has a volume of 344 cubic units. Find its volume if 2 dimensions were tripled and the 3rd dimension was doubled. Alright, so we've got, my volume I know is going to equal length times width times height. And let's call this the volume of the old. And now the volume of the old equals 344. Now let's talk about the new. Volume is going to equal, let's say, the 3rd dimension was doubled. I'll just start with that. Let's just say that 2 times L times, and then the rest were tripled. 2 dimensions were tripled. 3 times width times 3 times height, right? And so the volume of the new is going to equal, oh, very nice, 2 times 3 times 3 times L times W times H. You guys see where I got that? It's just, I'm just mixing up the numbers. I'm still multiplying them all together, I'm just kind of rearranging them. Well, that equals 18 length times width times height, right? Do I know what my length times my width times my height equals? Yes, I do. And just like when it was up here, and we just decided, well, the new volume is whatever you multiply the old sides by. It's the same here. The new volume is just the old volume multiplied by whatever we multiplied those sides by. Here's my old volume. Here's what I multiplied each side by. So, $18 times 344, and that equals 6,192 units cubed. Okay, so that one's a little bit weird. That one's, I can feel people were like, Mr. Kelly, I was with you until you started doing that. But let me recap. When you're given a question that gives you the volume of an original cube And then it says, I'm going to multiply one side by 2, one side by 3, and the other side by 3. Take what they multiplied each side, just multiply those numbers together, and multiply that times the original volume. Alright, this is the same thing, except now, instead of multiplying it by the whole number, doubling it, so much we're multiplying it by a fraction, half. So now, half is long, half is wide, heights are equal. Go ahead and try it and see if you can figure it out. Do it the same way you did with this. Play around with it. I don't mind if you can't do it, just mind if you don't. Please take those out. But instead of volume equals just that, it's still volume All right. So this is a tough one. Has anybody come up with the volume ratio? I heard, yeah? Say it again? Okay, I've got a 5/3. I heard a half. I heard 1/8. Anybody else? So you see how difficult this is. This is not an easy one. Okay. So here's how I want you guys to take this. We've got A right here, and let's just call this length, width, and height. So the volume of A is length times width times height, right? And volume of B is 1/2 width, oops, 1/2 length, and then height. And so, if we take that volume B and we multiply the two 1/2s together, what is 1/2 times 1/2? 1/4. 1/2 times 1/2 is a quarter, right?
Yeah.
length times width times height. So, if volume A is just length times width times height, and volume B is 1/4 of length times width times height, what's your ratio? 1/4. 1/4. Why? Because this volume is going to be 1/4 of this. This is your big box, 4 is your big box, and 1 is your small box. Okay, once again, all you have to do is figure out what the sides are being equal to, being multiplied by, multiply that together. Yeah, you got to do 1/2 and 1/2. That's it.